Welcome to The Explainer. So glad you're here, because today we're unpacking a massive, fundamental friction right at the core of our modern world. We're talking about the absolute collision between the messy, unpredictable reality of human life and the rigid, cold, mathematical logic of computers. When we try to write the rules that govern society into digital hardware, these two completely alien universes just crash into each other. After all, you can't exactly argue with a computer program that you were only going 5 miles over the speed limit.
And it's a collision that forces us to ask a really gripping question. Can a perfect rule actually survive reality? It completely challenges everything we assume about automated law, smart contracts, and artificial intelligence. Are we actually engineering a perfect system, or are we just building brittle rules that shatter the second they touch the real world? Okay, let's dive into this.
Here is our roadmap for today. We're going to cover wet code versus dry code, the limits of literalism, building the legal DOM, the semiotic bridge, and finally, the human in the loop.
All right, Section 1, wet code versus dry code.
So, on one side of this ring, we've got wet code. This is our traditional human law, or what researchers sometimes playfully call our fuzzy OS alpha. It is inherently ambiguous, highly relational, and, well, forgiving. We humans, we bend rules when the context demands it, right? But on the exact opposite side, we have dry code, the language of machines. Operating strictly on Boolean logic deep down in a processor's arithmetic logic unit, this stuff is purely deterministic. It's unyielding, it's cold. It literally doesn't care if you had a bad day. If the math says no, the code just does not execute, period.
Moving on to Section 2, the limits of literalism. Now, for a lot of technologists, applying that unyielding dry code to human behavior, that's the ultimate dream. Take a look at cryptographer Nick Szabo's concept of the vending machine primitive. Think about how a vending machine actually works. You put $1 in, and a soda comes out. There is zero human judgment, zero nuance, and absolutely no judge standing there deciding if you quote-unquote deserve a soda today. For strict coders and formalists, this pure autonomous execution is exactly how all contracts should work. But here's the catch. Pure digital formalism, it inevitably shatters when it hits the real world. Why? Because laws are human speech acts, they aren't math equations. For example, when technologists tried to introduce a reasonable coder test to evaluate smart contracts, it completely failed because everyday people simply don't read machine code. Plus, history consistently shows us that courts actively reject strict literalism to protect the public. Look at landmark precedents like the Supreme Court of Canada's Pacific Coast coin decision. The court completely ignored the clever technical structure that coders slapped onto a transaction, and instead, they prioritized the actual economic reality to protect the humans involved. The big takeaway here is that human law simply has to remain adaptable.
Which brings us to Section 3, building the legal DOM.
So if the law absolutely must remain fluid, how on earth do we translate it into rigid executable data without completely shattering our legal system? Well, the engineering fix here is what we call the legal DOM, or Document Object Model. You can think of the legal DOM as the hidden plumbing or the digital skeleton of a house. Instead of treating a law like just a flat, dead wall of text in a word processor, it uses global standards like a Coma Nentoso, which is basically an international blueprint for formatting legal documents, to map chapters, clauses, and subsections into highly structured, living XML data. It gives the abstract a concrete digital skeleton that hardware can actually understand and safely execute.
Let's move to and see how this builds out using the FRBR hierarchy. It's a framework that tracks a concept all the way from a spark of an idea down to a physical file. We start at step 1, the work. This is the purely abstract, raw human thought of a law. Then, step 2 is the expression, maybe translating that thought into French or drafting a newly updated version. And finally, step 3 is the manifestation. That is the concrete, rigid XML file sitting securely on a physical server somewhere. We are literally tracking a fuzzy human concept all the way down to an exact atomic digital footprint.
Now, the real magic trick, making all of this possible, is the BI-DOM synchronization pattern. Think about it. If XML is so incredibly rigid, a human lawmaker couldn't possibly type in it without instantly breaking the code, right? So the system brilliantly runs 2 layers at exactly the same time. There's a lightweight, highly intuitive editor DOM for the human, allowing them to draft naturally and visually. And then, working silently in the background, there's the stored DOM, translating every single keystroke into unforgiving, schema-validated XML code. The human gets to act human, and the machine processor gets its absolute mathematical truth. It's brilliant.
All right, moving on to Section 4, the semiotic bridge. But before we actually cross that translation layer, we really have to respect what's called the modality gap. This is that massive, fundamental disconnect between how we think, purposeful, highly context-dependent, and how a computer operates with absolute, discrete literalism. And here's the thing, we cannot just toss probabilistic AI at this gap and cross our fingers. If we rely entirely on AI pattern matchers to guess what our laws mean, we run straight into a major risk researchers call fax machine decay. That's where the system loses fidelity with every single copy, eventually hallucinating outputs instead of enforcing exact legal facts.
So how do we bridge this gap safely? The answer is simple but profound. Text is the universal interface. Strictly formatted text, things like JSON or Python scripts, is quite literally the only way to safely squeeze our continuous, highly associative imagination into the discrete, quantized electrical packets required by a machine's arithmetic logic unit. Text is the ultimate deterministic script binding these two completely alien worlds together.
And this brilliantly illustrates the concept. Just as wooden posts draw a stark, unyielding line and shifting sands, drawing explicit structural text boundaries allows us to define reality in the digital realm. By creating these highly formal textual boundaries, we can explicitly generate legal monopolies and trigger real-world legal effects with absolute mathematical certainty. Which brings us to our final segment, Section 5, the human in the loop.
But you know, all that mathematical certainty comes with a massive caveat. When we rely too heavily on automated logic, we create what tech scholar Madeline Elish calls moral crumple zones. It's a terrifying but honestly brilliant concept. Just like the physical crumple zone on your car is designed to absorb the brutal impact of a crash, highly complex AI systems are often explicitly designed with a human operator in the loop just to absorb the legal liability. The sheer overwhelming complexity of the machine's logic obscures responsibility, leaving the human sitting there to take the hit when the algorithm inevitably fails.
To combat this, we absolutely must protect the role of the sovereign human pilot, because the magic, it's never actually in the machine, it is entirely in human intent. The system still desperately needs the traditional legal concept of the sweat of the brow, meaning the active, manual, hard work of human authorship is required to orchestrate semantic meaning. We can't just be passive consumers of AI output. True determinism requires active human stewardship to bend that rigid, unforgiving deterministic script back toward a moral human mandate. And that brings us to the core takeaway of this entire explainer. I want to leave you with this final provocative thought. If we build systems that attempt to completely remove the human author, if we fully surrender to that vending machine primitive we talked about, who actually takes responsibility when the code inevitably breaks reality? Are we really ready to hand over the living, breathing context of justice to cold silicon? Think about that the next time you interact with the automated rules shaping our world. Thank you so much for joining me today, and I'll see you on the next explainer.